Okay, this is a little demonstration of more advanced firing routines for the shoot 'em up construction kit. I'll show you what I started with. It's this object here, which is the swivel gun of a tank, as in any SEUCK game. When you're making a large object like a tank or a vehicle of any sort, really, you generally have to piece it together from different spreads, so this is just 1/8 of the whole tank. But because this is supposed to be a swivel gun, it was unfortunately limiting that SEUCK does not allow for many different firing options. The default ones just don't cut it. They're either firing in one direction or in random directions, and as you can see, this gun would not have been able to turn fully 360 degrees, so it would have been very unrealistic to have it firing backwards, for example. There was a way around that. I could have drawn a bullet object that was invisible if firing in the directions the gun can't point, but there's still always the sound effect of it firing unless you're cutting out sound altogether, so that isn't very satisfactory. So what I wanted to do was to see if I could synchronize animation and with a reprogrammed fire routine so that it would only fire in the direction it's pointing, and this is how we got there. So we go into the enemy bits where we see the standard options for the enemy. Now the firing pattern I selected was one I'm not planning to use in the game at all, which is crossfire. And we can find the cross-firing routine, or we can normally find it in the program. We'll go into Machine Code Monitor, and you would find this at 5368. Oops, that should be D5368, always D when you're just looking up. So, compare 09. 09 is a bit of data, the nibble, half a byte, which indicates this particular firing type, which I learned after I eventually chased up that enemy bits data from where it is in the program and looked at the actual numbers. It was a lot of detective work, but we got there in the end, and I found out that 09 indicates the crossfire pattern. So knowing that, I was able to go in and change this code to this block here. So I'll leave that up for a bit. What this is doing, if it's not 09, it just moves on to the next bit of code. Which it's not very apparent what it is there, but that's... yes, it looks corrupt there, but it isn't. That's just because of the difficulties in displaying machine code. If I was to go up here and then turn that into D5388, you can see what it really... yes. So yes, if it's not 09, if it's not the crossfire pattern, it branches ahead, branch if not equal to there, and it checks it against the next firing type there. But that's not important. What is important is it is this type, so this is where we get on to the reprogrammed routine. And this is where we have to set up what is basically a little table of data for it to read from, which tells it the new firing pattern. So that's 2CD4 is a simple count, a timer. So we load that into the X register, and then we start a count in the beginning of the table. The table runs from 2CD0 to 2CD3. So there are 4 parts to this firing sequence. So we run through it by putting the X on there. The STAOB, that is where it sets the actual firing direction. But then the next bit is where it moves the timer on. And then if the timer has reached 4, it knows it has to move the timer back. So we put 0 into 2CD4. And there we end it with jump 53D2, which is just moving on to the next part of the program now that the firing is done. Now, we need to look at this data table. It doesn't need to be here, but I'll show you why I've put it here. So, 2CDO is in fact, if we look through our data here, it's the player 2 bullet. It's the frames of the player 2 bullet. 2CDO, 2CD1, D2, D3, and the timer at D4. So you can put this anywhere where there's spare data, where you don't need this, because there's no player 2 in this particular game I'm making. If there's a player 2 in your game, maybe you can put it in enemy death 8 or something like that. I'll show you how to find spare data. So if we go into Machine Code Monitor again, and we have a look at 2CDO, we're now into the enemy bits area, the enemy objects area rather, and everywhere there is a 7E, that 7E corresponds to the number 126 in normal decimal. So those are empty frame tables. So you count through those and you should be able to find ones that you're not using. See, that's empty, that's empty. These will all look like long strings of 7E in the Machine Code Monitor. So the nice thing about doing it this way is because you can just take the sprites and put them there and change your data easily. If you want to do it that way, it doesn't really matter. But the numbers, I will read them out to you. They correspond to different firing directions. That 5 is southeast, the 4 is directly down, the 6 is southwest, and the 4 is directly down again. And that last one is just the timer, which is counting through the sequence from 0, 1, 2, 3, and when it hits 4, it goes back to 0 again. So it just keeps running through this sequence. So, southeast, down, southwest, down, and back again. So the gun should swing back and forth and fire in sequence. The full set of directions is number 1 corresponds to right, number 2 corresponds to left, number 4 down, number 8 up, 5 southeast, 9 northeast, 6 southwest, 10 northwest. However, 10 would be written in Machine Code Monitor if you're doing it that way as 0A, because there is no decimal 10 in hex, which is what the language we use for machine code. So let's have a look at that in game. And there it is, firing nicely, just the way we want it. There is one small problem to this though. We have to make sure every time we start a new game it's still correctly synced, because it won't be by default. Now the way we do that is we add an extra bit to the init game routine. So 41A4. This is where we need to add a new bit. So first of all we jump to an empty area of code. Now the area of code I've picked here is the routine that adds the score in, which you may or may not need. If you want there to be scores in your game, you will not use this routine. This bit isn't actually essential. It depends if you really want the animation to sync. If you're just interested in different firing patterns, then you already know enough. But if you want to make sure that they're properly synchronized, then you will have to find an extra area of code, unfortunately. But it needn't always necessarily be a very long one. In fact, let's have a look at it, and it might even be you can get it in one of those spare blocks in the object frame tables where it's just 7E off 7E. Let's see what we actually have here. D5, oh, wait, let's do it down the end of the screen so we can get all the code in. D5BA6. So what we have here is not actually very long. We just take the number 1, every time the game starts, plug that into the timer that we saw before at 2CD4, the last frame in that table, and then that line always finishes an init game routine, jump 4260, because that's what the line 41A4 normally looks like. So whenever you're patching in new code, you always replace the original line that you overwrote to patch in. So that is actually enough to synchronize it. So that's how many bytes? That's 1, 2, 3, 4, 5, 6, 7. That's only 8 bytes. So you won't need much to put that in if you're only doing this for one enemy. So let's kill this little guy. Make sure it all synchronizes nicely. Start again. And there it is. The gun is still firing in the correct direction. So, that's a quick demonstration of more advanced firing routines on Shoot 'em Up Construction Kit. Okay, please feel free to contact me if you have any questions, and well, happy programming. Ta-ta.